So we'll start with the graphs y equals a to the power of x, where a is greater than 1. So obviously your a is going to be a number. So it'll be y equals, for example, 2 to the power of x. That graph looks, if you went and graphed it by hand, this is what you'd get. Something that looks like that. Down here on the x-axis is an asymptote. So on the left-hand side down here, it approaches that asymptote but never touches or crosses it. So it gets exponentially close to the x-axis. So that was 2 to the x. It'll cross at the point 1. Because y of 2 to the power of 0 is 1. Yep. So any normal function where it's y equals something to the power of x, it'll always be a y-intercept of 1, because no matter what number you have, if you raise it to the power of 0, it's always 1. Yep. All of these graphs are related by dilations from the y-axis. So if, for example, we have y equals 10 to the power of x, it looks like the y equals 2 to the x, but it's more squished up. So it kind of goes like that. Still crosses at 1 though. And there's still an asymptote on the x-axis. Y equals 0. Okay, so all these types of functions are just related by dilation. So they either squish it in or expand it out. So y equals a to the x, where a is between 0 and 1. Can a exactly equal 1? What kind of line would you get?
Straight.
Yeah, it'd just be y equals 1, because no matter what you raise to the power, what you raise 1 to the power of, it's just always 1, so you just get a straight line. Yeah, so it's either got to be more than 1 or less than 1. So a between 0 and 1 looks like this. It goes the opposite way. So this one would be y equals 1/2 to the x. You can also write 1/2 to the x as 2 to the negative x. Because 2 to the negative x puts the 2 to the power of x underneath the 1. It's the same as if you have the x on the outside of the bracket. And where do you think it crosses the y-axis? Yeah, at 1. So it looks just like y equals a to the x, but reflected in the y-axis. Next one. Y equals a to the power of x plus c. Thinking about the graph y equals a to the x, what do you think the plus c does? Moves it up or down if it's negative. Yeah, perfect. So if we have y equals 2x plus, oh, sorry, no. Both. Yeah, it moves the asymptote up and the graph. Y equals 2x plus 3. So it'll look exactly like y equals 2 to the x, but moved up 3 spaces. So now we had a asymptote on the x-axis. Now we have an asymptote at 3. Y equals 3. And where do you think the graph is going to cross the y-axis? 4. Because it was 1, gets moved up 3 spaces. It's now at 4. So it looks just like it did before, but moved up. Like that. Same as if it was a minus 3, it'd be the same graph, it just moved down 3 spaces from the x-axis. So this one is y equals 3. This one is y equals 2 to the x plus 3. Remember, you should always write your asymptotes as an equation. They're not just a number.
How do you spell asymptote?
A-S-Y-M-P-T-O-T-E. Asymptote. All right, next one. Y equals negative a to the x. What do you think the negative does?
Flips it in the x-axis.
Yes, flips it upside down. So before having an a that's between 0 and 1 flips it over the y. Now having a negative a flips it over the x. So if we do, for example, y equals negative 2x, there's still the same asymptote along here. But now it goes down this way. What would this y-intercept be? Negative 1. Yeah. Nice. That would be y equals negative 2. Oh, sorry, to the x, not 2x. Oh. I just erased it. Did everyone get that down? Yeah, okay, good. Next one is y equals ba to the x. So what you're doing is multiplying your 2 to the power of x, for example, by a number in front. So what it actually does is it's a dilation of b units from the x-axis. So every y value is going to be multiplied by, on the example we have on the sheet, 3. So if we had y equals 6 to the x, that's actually y equals 3 times 2 to the x. So every y value on the graph is going to be 3 times larger than it was before. So all the x values stay the same. So if you had an x value, for example, at 1, 2, right? If x equals 1, y equals 2, it's now going to be at 1, 6. All the y values are now 3 times larger. No, it's still going to be 1. I think no, it's not. It's going to be larger. Yeah, it's going to be 3. Yeah, it was 1. It's now 3 times larger. It's 3. Yeah. So this was the one before. And if we make every y value 3 times larger, we're actually going, it would kind of start in the same spot, but then get bigger and bigger. So for example, this point here, right, this y value, it'd now be 3 times larger up here. And the y-intercept is now 3. Because it was 1, 3 times bigger.
You only times the y-intercept? Or the both of them?
It's only the y values that are getting multiplied by 3. So this one would be y equals 6 to the x, or y equals 3 times 2 to the x. Yeah. You don't have to. No. But it's just a way to know like what the graph would look like. Sorry guys, you can't write it that way. That doesn't make sense. So if it was just written that way, then that's fine. Yeah, sorry guys, got confused. Yeah, not 6. Because you can't go from 6 to 3 times 2 to the x. Yeah.
What would 6 to the x look
like? It would look like, it would look just like the very first one we did, where we did y equals 2 to the x and then made it y equals 10 to the x and it gets squished in. It would look a little bit more squished in than 2 to the x. But it would still go through 1 y-intercept. Yeah. Sorry. We're all good with that one? Not confused? This is only if you have a number multiplied in front. Yeah, so, yeah, like that. Yeah, if it was just 6 to the x, it would have been the first situation that we looked at, where it's just squished in but still goes through 1.
So it's got a more... okay.
Yeah.
So the main difference is the intercept.
Yeah, that's the main difference. It still looks squishier. Yeah. Yeah. Okay, next one is y equals a to the x over d. Now, it's not written anywhere as d. I just chose d as a value because we'd already used b and c and a. So d is just my own little invention. Just means a number. Right, so this one looks like y equals a to the x, but with the dilation of d units from the y-axis. So in other words, all of your x values are now going to be d times bigger. So it's going to move, if I do it your way, that way along. Everything's going to stretch out sideways. So if, for example, we have y equals 2 to the x, and instead we did y equals 2 to the x over 2, all of our x values are now going to be 2 times larger. So, for example, this x value here would move 2 times larger to here. It actually starts off a little bit higher. I'll do it in a different color. And then it goes a little bit under. at the y-intercept.
That's
Like that. So that's y equals 2 to the x over 2, or 1/2 x. So yeah, all of our x values are being pushed 2 times further. So this one here, it starts slightly over it and then goes slightly under it. If you were to graph it by hand for each x value, you'd see that happen. Go slightly over and slightly under.
Are we going to be asked to graph or just
Maybe. Yeah. I mean, if it's something like 2 to the x, you can do that because you just choose values of x. So 2 to the 0, 2 to the 1, 2 to the 2. You just plot it and join it up. Okay, we're drawing slightly off. Yeah. All right, let's fix this up. This actually goes through the same y-intercept. Yes, Oz. There we go. So yeah, it still goes through 1.